Hey there everyone, welcome to Chapter 5, Section 1, Properties of Polynomial Functions. Let's go over what it means to be a polynomial function. It means the exponents are all whole positive numbers, so no negative exponents, no fractions as exponents, no letters inside your exponent, like don't raise anything to the power of x, something like that. Coefficients are all real numbers, so no imaginary numbers, nothing with I in it, nothing with the square root of a negative number or anything like that. And a polynomial function is in standard form when its powers are written in descending order from left to right, so they need to count down, basically. And then the highest power of a function determines its degree. So looking at example 1, I have 3x squared minus 5x plus 8. So that's going to have a degree of 2 because that's the highest power and a leading coefficient of 3. It's just whatever goes by that power. So example 2, 6x squared minus 4x to the 8th plus 7 plus 3x is not written in standard form, but its leading coefficient would be negative 4. And its degree would be 8 because that's with the highest power. So the standard form would look like negative 4x to the 8th coming first, then it was a positive 6x squared, so plus 6x squared, plus 3x, and then plus 7, plus 7. So everything's got to be in order. So in these examples, determine whether each function is a polynomial function. If so, write it in standard form and state its degree, type, and leading coefficient. By type, I'm just going to go with identifying it as an odd function or an even function. And we'll talk a bit more about it in the second section. But I think that's all. That's really all we need to cover. So is this a polynomial function? Yes, it is. So yes, a PF function, or PF. All right. Is it in standard form? Do the powers count down in order? Yes. So also yes, in standard form. And is it an odd or an even function? So that tells you whether it's odd or even, so it is an odd function. All right. Let's just look at C. I'm right here. So I have the power of negative 1. So that means no, it's not a polynomial function because of the power of negative 1. There, so I typed it because I got tired of writing. So no, not a polynomial function, not a polynomial function because it has an exponent of negative 1. All right. So that's all we need to say if it's a no. So letter B, I have negative 0.8 x to the third plus the square root of 2 times x to the fourth minus 12. So are the exponents whole positive numbers? Yes, they are. Are the coefficients real numbers? They're decimals and square roots, but that's still a real number. So yeah. Is it in standard form? Well, okay, so we just answered, is it a polynomial function? Yes, it is. All right, and then is it in standard form? No, it's not in standard form, so let's write it in standard form. So all I'm going to do is I'm going to say g of x equals, and then the square root of 2 comes first, and then x to the fourth minus 0.8x to the third. So just keep the signs the same, If it's positive, put a plus sign in front of it. If it's negative, put a minus sign in front of it. And then, yeah, that's it. So I'm going to try and fix this x here for a second. Erase this a little bit. Does that make it any better? I don't know. All right, so now it's in standard form. What's the degree? What's the leading coefficient? What kind of function is it? So I'll write that right here. The degree is 4, because that's the highest power. The leading coefficient, I'll abbreviate as LC, is the square root of 2. And then the type is, well, the degree was 4, so that's even. All right? So yeah, there's everything on B. On D, this is not a coefficient, not a polynomial function, because it has x as an exponent. So that's all you need to say on letter D. So let's move on to the next section of the notes. All right, so here we're going to talk about the end behavior. So I'll read you the definition. The end behavior of a function's graph is the behavior of the graph as x approaches positive infinity or negative infinity. For the graph of a polynomial function, the end behavior is determined by the function's degree and the sign of its leading coefficient. So what does that mean to you? It means that if you have an odd function and the leading coefficient is positive, it's going to go like this. If you have a negative function, it's going to go like that. So odd functions that are positive will go up from left to right. Even functions that are positive will go up from left to right as well, but they're both going up. And then negative functions, or negative leading coefficients, will go down from left to right if it's odd, and then if it's even, they'll both be going down. So I think I just kind of summed up everything right here. Even, both go up if it's positive, both go down if it's negative. Odd, and what I mean by both is the tails of the function, all right? And then odd is one up, one down, so it'll start down, up if it's positive, or it'll go up, down if it's negative. You can kind of think of it like that. So I have these examples right here. Describe the end behavior of the graph. So we have a degree of 4 and a leading coefficient of negative 0.3. So degree is 4, so that's even. Really, that's all that's important. And then the leading coefficient is negative, all right? So because it's even and negative, we just look at this. So it's going to go down, down, all right? So f of x, that's basically y, goes to negative infinity as x goes to negative infinity. You're welcome to just copy this over. What it's saying is the y values go down as the x values go down. And what it's saying over here is the y values go also down, negative infinity, as the x values increase, so go up. So yeah, it's kind of confusing, but I guess I'll say the y values go down as the x values go left, if you want to think of it like that. And the y values go down as the x values go right. I don't know if that helps, but that's basically kind of what we're saying. So example 2 here, we have a degree that's odd and a, what is this, 0.25, that's even. I mean, that's positive. So 0.25 is odd. So our degree is odd, and our leading coefficient is positive. So that means we're going to look over here with the odd positive. So the y values are going down as the x values are going left. The y values are going up as the y values are going right. So if you want to just copy it over, feel free to do so. But y values going down as x values go left, and then the y values are going up as the x values are going up. Okay? If it also helps, your x ones are always going to stay negative and positive. So the only ones that you really need to change are these, the y ones, the f of x, if that helps. All right? So the last section here, using the graph, describe the degree and leading coefficient of the polynomial function. Well, just look at it. It's going like this, right? So feel free to use this. This is a degree odd, and it's going negative because it's going opposite directions, and then it's going down from left to right. So the leading coefficient must be negative. This other one has to be odd because the tails also go in opposite directions, but since it's going up from left to right, it must be positive. All right. This one is the tails are going in opposite directions, and it's going up from left to right. So the degree is odd. The leading coefficient would be positive again. All right. So all we're looking at is just the end behavior, so the tails of the graph. So these are both going up. So if they're both going the same direction, the degree must be even. And if they're both going up, it has to be positive. If they're both going down, it'd be negative. So other than that, thanks for watching. If you're one of my students, do the exit quiz. I normally don't have this part on it, but Yeah, thanks for watching, and hope this helped, and goodbye.